Gamma ray bursts, dark matter, black holes, neutron stars, and supernova remnants. Clues to these mysteries of the universe and more will soon be investigated by a new intergalactic detective. The Gamma Ray Large Area Space Telescope, known as GLAST, is poised for launch aboard a Delta II rocket. GLAST will be the first observatory of its kind to daily survey the entire sky using its highly sensitive instruments. Join us now from the Kennedy Space Center in Florida as we learn more about the exciting mission of GLAST.
Hello and welcome to NASA's special coverage of the GLAST mission. I'm your host, Tiffany Nail. In addition to taking a closer look at this exciting mission, we're going to visit a location that NASA viewers only glimpse during launch coverage. It's the Mission Director Center where the launch team conducts the countdown. We'll also hear from a member of the GLAST team who stopped by the studio earlier to answer some questions about the goals of the mission. But before that, our mission manager here at Kennedy, Bruce Reed, is going to introduce us to the spacecraft and rocket.
Hi, I'm Bruce Reed, Mission Manager for the Launch Services Program here at Kennedy Space Center. It's my job to act as the primary coordinator between the spacecraft and the rocket that will carry it to space. The GLAST spacecraft was built and tested for NASA by General Dynamics in Arizona. The spacecraft was transported across country where it received additional testing at the Naval Research Laboratory in Washington. In early March, GLAST arrived by truck at Astrotech's processing facility in Titusville, Florida, located just across the Indian River from the Kennedy Space Center. Over the last 2 months, final pre-launch preparations of the spacecraft were completed in the facility's clean room. Engineers and technicians have been busy checking all the spacecraft's communications, command and data handling, and propulsion systems. In addition to a complete checkout of the craft's scientific instruments, the flight battery was installed along with a communications antenna and 2 sets of solar arrays. Meanwhile, just miles away at Launch Pad 17B, the Delta II rocket has been undergoing its own preparations by its builder, United Launch Alliance. The Delta II has proven to be a workhorse launch vehicle. For the GLAST launch, the rocket will use 9 strap-on solid rocket boosters for additional lift capacity. With the first and second stages in place, the rocket was topped off by the spacecraft tucked inside a protective fairing. The stage is now set, the rocket and spacecraft are ready, and soon the familiar 3, 2, 1 liftoff will send GLAST spaceward to fulfill its mission.
I'm here in the Mission Director Center with NASA Launch Director Omar Baez. Omar, thanks for joining us.
Thank you, Tiffany.
This is where the launch team works during the countdown. This place is full of activity in the moments leading up to launch. Can you show us your console and tell us what you do during the countdown?
Sure, Tiffany. This is my console. It's my communication station. I also have video in here, closed circuit TV of what's going on. And this is where I perform my polls at different phases of the launch.
A question that our viewers always ask us is, do you actually push a button to launch the rocket?
No, I actually don't push a button, but 3 miles down the road, there's a gentleman called the first stage controller who actually clicks a mouse at T-minus 3 seconds and enables the engines to start on the rocket.
Can you explain to me what some other key members of the launch team do on launch day?
Sure. If I start at the back of the room, we have our safety and mission assurance personnel. We also have our public affairs officer doing the live commentary. We have our spacecraft customer. We have the Air Force landlord of Complex 17. We have the launch service provider, the mission integration team, and behind me I have my management.
Thanks, Omar, and good luck on launch day.
Thank you.
Once GLAST is in orbit, NASA's Goddard Space Flight Center takes over as the spacecraft gets set to help unlock the mysteries of the universe. The mission is a cooperative effort between NASA, the U.S. Department of Energy, international partners from France, Germany, Italy, Japan, and Sweden, plus a number of academic institutions from the U.S. and abroad. Here's GLAST project scientist Dr. Stephen Ritz to answer some questions about the purpose and goals of the GLAST mission.
Among the many areas of scientific investigation that we'll be doing with GLAST is a phenomenon called gamma ray bursts. Gamma ray bursts have been well studied before, but we don't know very well at all about their highest energy emission. And that's very important to understand so that we can understand what's under the hood of these incredibly powerful engines. Together, the two instruments, the Glass Burst Monitor, or GBM, and the Large Area Telescope, LAT, cover, for some phenomena such as gamma ray bursts, 7 decades in energy. And that means that if GLAST were an instrument like a piano, it would cover 23 octaves. And so that's an incredibly huge breakthrough all by itself. Now the LAT will provide for us those breakthrough energy range measurements, and we'll be able to do that with exquisite time detail as well, and that's an incredibly important advance. However, we really need to know burst to burst, and they happen about once a day, what the lower energy behavior is as well. As our colleagues say, when you've seen one gamma ray burst, you've seen one gamma ray burst. They're all different. And so it's important to match the lower energy measurements of gamma ray bursts with the higher energy measurements that the LAT will provide. And that is an important role that the Glass Burst Monitor, or GBM, plays. GLAST is a multi-agency, multicultural, and multinational mission. That's one of the things that's really great about it. NASA is working together with the Department of Energy in the United States, and that represents the cooperation of different communities, in particular the high-energy astrophysics and high-energy particle physics communities. These communities have come together to make something very special, which is GLAST. So that's the multi-agency and multicultural aspect. It's also multinational. There have been central contributions from Italy, Japan, France, Germany, and Sweden. And together, these combined talents have made GLAST a reality. GLAST is designed to operate for 5 years, and we have a goal to operate for 10 years. Since there are no consumables on board, which means there's no gas or other things that get used up, we think we can do that.
I hope you enjoyed the program. I want to thank all our guests for giving us this inside look at what goes into a successful launch and mission. Join us live for the GLAST liftoff on NASA TV or on your computer at nasa.gov/GLAST. Thanks for joining us. I'm Tiffany Nail.